Well, here we go again. We're going to find any critical numbers for this function that happens to have a square root in it. And, as is our usual, we're going to first investigate the function itself. Does it have any undefined values? And the answer is most certainly yes. If the square root is encompassing or over a negative number, it would be not real. So we are going to determine when is this function defined, and that happens, it's defined if the x plus the 1 is greater than or equal to 0. The square root of 0 is real, that's equal to 0. And the square root of anything positive is positive, but the square root of negative is not real. And we end up here that x must be greater than or equal to negative 1. And if we were to look at it as sort of a graph on the number line and just looking at the x-axis alone, that means x could be negative 1 or anything larger than negative 1. I don't know exactly what this graph looks like. I definitely know what square root looks like, but what happens when I multiply by x? That's not the question. We're just looking for what's called the critical numbers, which can turn into critical points of the graph. So now we do our derivative. A product rule. X multiplied by another function of x. So the derivative of x is 1. We will leave the square root of x plus 1 alone, plus leave x alone. Remember square root? That's really the 1/2 power, a little scratch paper here. So it's going to be 1/2 quantity x plus 1, subtract 1 from the exponent, negative 1/2 power, and then we multiply by the derivative of the x plus 1, which happens to be just 1. That would be called the chain rule. It's a little bit of a mess, so let's do a little cleanup here. Square root of x plus 1. Let's see. So that's in the denominator, that's in the denominator, plus x over 2. Instead of writing it the 1/2 power, I'm going to go back to our square root x plus 1. And we sort of repeat that initial question. When is this undefined? Well, this is undefined for the same values as the original, but there is something different here. If x is actually a negative 1, and negative 1 plus 1 is 0, the square root of 0 is 0, 2 times 0 is 0. We cannot have 0 in the denominator. So if we look at the defined values, they're not exactly a match. We know that x cannot be a negative 1 in this case, and then otherwise it's exactly the same as that. Another way to look at it is this is defined if x is just greater than negative 1, strictly greater than. So that makes it a critical number, defined on the function, undefined in the derivative. Okay, so I have to make sure to mention that at the end of the problem here. And now we'll go to the fun part. The reason I really chose this problem is I like solving this. Oh, solving for what? Oh yeah, that would be solving for this equal to 0. Now, there are ways of just doing this algebraically, moving terms over, but I would like to leave the fraction intact so that we can separate our undefined values from our values equal to 0, because a fraction is 0 if the numerator is 0. But in order to add these two expressions together, I need a common denominator. I need this to read 2 times the square root of x plus 1. But I can't just write that there because I want to. I must multiply the numerator by 2 and the square root of x plus 1. Oops, got a little bit messy. Your guys' paper never did that, did it? Then I end up with 2 times square root times square root. That'll be just x plus 1 to the first power. And that's 2 root x plus 1 plus the second fraction, 2 square root x plus 1 is 0. And since they now have a common denominator, I can write this as 2x plus 2 plus x over 2 multiplied by the square root of x plus 1. And a fraction is equal to 0 when the numerator is equal to 0. 3x plus 2 equals 0. 3x is a negative 2. X would be a negative 2/3. Now, let's combine the information we've gathered. That's a critical number because that is where the derivative is 0 and it's part of the defined values of the function. X equals negative 1 is a critical number because it's defined in the function but not in the derivative. Although there are books sometimes will state that if the undefined value is at an endpoint, and an endpoint, it may not be called a critical number. I'm going to call it that way because that's the definition we've been working off of, but I'm just admitting that there are variations in other books. So our critical, you can't read that, there we go, our critical numbers will be negative 2/3 and x is negative 1. There you have it. A little bit heavier lifting in this problem, but I hope it was beneficial to you. Until next time.